Unit 7, opener number 7, focuses on solving quadratic equations using the quadratic formula. Since we have a lot of quadratic equations here to solve, then let's get right to it. When I look at part A, I see that when I need to use the quadratic formula, I know that my quadratic equation needs to be set equal to 0, and this quadratic equation doesn't equal 0, it equals 9. So we need to make sure to get it in the right form before using the quadratic formula. So I am going to take away 9 from both sides of my equation, and now I have opposite of x squared plus 6x minus 9 equals 0, which is in the right form to use quadratic formula. My a is -1 because it's the coefficient of x squared. My b is 6 because it's the coefficient of x. And my c is -9 because it's the constant term. So x equals the opposite of 6 plus or minus the square root of 6 squared minus 4 times -1 times 9 all over 2 times -1. What I like to do first in order to keep myself organized is I like to simplify what's underneath the radical. This one's an interesting one because we get 36 minus 36, which is 0. So we have -6 plus or minus the square root of 0 over -2. To keep myself organized, I split it up into two parts. -6 plus square root of 0, which is 0, over -2, and -6 minus 0 over -2. Well, -6 plus 0 is -6, divided by -2 is 3. -6 minus 0 is also -6, divided by -2 is also 3. So what we see here is we actually only get one unique solution. X is just equal to 3. This happens every time we have 0 underneath the radical, because when you add 0 or subtract 0 to the number that you started with, you end up with the same thing. So anytime we have 0 underneath the radical, there's actually only going to be one solution for that quadratic equation. As we move on to part B, we see that this quadratic equation is not in the right form to use quadratic formula either. So I'm going to subtract 11 from both sides of the equation and get 2x squared minus 11 equals 0. A is my coefficient of x squared, which is 2. B is my coefficient of x, but x is missing, there aren't any, so I have to put 0 as my b. And then c is my constant term, -11. So x equals the opposite of 0, which is just 0, plus or minus the square root of 0 squared minus 4 times 2 times -11, all over 2 times 2. So I get 0 plus or minus, and then once again I like doing what's underneath the radical first. And I get 88. So I'm going to have the square root of 88 over 4. Square root of 88 can be simplified, or we can find a decimal approximation, but it's not a perfect square. I think for our purposes right now, I'm actually just going to leave the final answer just with the square root of 88 in it. So I'm just going to say, instead of 0 plus or minus, whoops, I keep shrinking this down and zooming in too much, so let's see if we can get it to a place where we can see it. For my final answer, I'm just going to say x equals, instead of 0 plus or minus, I'm just going to say plus or minus root 88 over 4. Maybe you simplified it, maybe you came up with a decimal approximation. For now, I'm just going to leave it like that. When I look at my equation in part C, I see that this one is definitely not in the right form to use quadratic formula yet. So first thing I'm going to do is distribute the -3x. I get -3x squared, and then -3x times -7 is plus 21x equals 9. Just like the other two examples, I need to get my quadratic equation equal to 0, so I'm going to bring the 9 over. So I have -3x squared plus 21x minus 9 equals 0. So my a is -3, my b is 21, and my c is -9. Before I start, though, I see that those are pretty big numbers, and I also see that they're all divisible by 3. So I think instead of using those values for my a, b, and c, I'm going to simplify this a little bit. I'm going to divide both sides by 3, since all of these numbers are divisible by 3, then I figure the smaller the numbers I'm working with, then the better the odds of solving my problem without making mistakes. I think I'll actually divide by -3 since that's the coefficient. Whatever I do to one side, I have to do to the other side as well. So my new equation that I'm going to be left with then is just x squared minus 7x plus 3 equals 0. That looks a little bit simpler. A is 1, B is -7, C is 3. If you don't do that, it's not a big deal, but I just thought it was a good opportunity to work with some smaller numbers. X equals opposite of -7, which is +7, plus or minus the square root of -7 squared. I have to make sure to use parentheses around my -7 so that I don't make mistakes when I go to type it into the calculator. And again, I'm going to do this part that comes underneath the radical first. I have 49 minus 12, which is 37. So x equals 7 plus or minus the square root of 37 over 2. Square root of 37 is definitely not a perfect square, and it can't be simplified. So I'm just going to leave that as my final answer and not even do any more with it. X equals 7 plus or minus the square root of 37 over 2. Moving on to my fourth problem, I finally see that we have a quadratic equation that's exactly in the right form for using quadratic formula. A is 5, B is 6, C is 3. X equals the opposite of 6 plus or minus the square root of 6 squared minus 4 times 5 times 3 all over 2 times 5. Once again, I'm going to do what's underneath the radical first. But this time I have a problem. 36 minus 60 is -24. Well, I can't take the square root of -24 and get a real number. I get something imaginary. So if I'm looking for all of the real solutions for x, I have to stop here and say that this one has no real solution. If we compare and contrast the problems that we've solved so far, we see that the first problem that we solved had a 0 under the square root and there was only one solution. The next two problems had positive numbers under the square root and there were 2 real solutions. And then this fourth one that we just finished solving had a negative number under the square root and there was no real solution. We'll summarize that after we do one more problem. Let's work on E together, and then F I'll save for you to try on your own. When I go to solve problem E, I want to check to see if my quadratic equation is set equal to 0. And right away I see that I have a serious problem here because not only is this not equal to 0, it's not equal to anything. This one is not even an equation. It's just an expression. We can't solve expressions. X could be anything. So in order to solve a quadratic equation using the quadratic formula, we need to make sure that what we're given actually is an equation. This one's not, so we can't even solve it. So our job is easy. Not an equation, can't come up with a solution for x. So to summarize what we did here, when we're solving a quadratic equation using the quadratic formula, we saw that we had a few different types of solutions. And there's actually a name for that. The b squared minus 4ac part of the quadratic formula, the part that's underneath the radical, that's called the discriminant. The discriminant helps you to determine how many solutions a quadratic equation has. When our determinant was positive, there were 2 real solutions. When our determinant was 0, there was 1 real solution. And when our determinant was negative, we got a negative number under the square root. There were no real solutions. Keep that in mind as you're solving quadratic equations using the quadratic formula.